electricity is not there, then if we are trying to switch on, and if there is nothing, because this is the first thing that is happening. This is the very first thing that is happening. And this itself will not have anything, then the system will not boot up. So this has to be non-volatile so that it will store the things. And RAM, you guys know, is it volatile or non-volatile? Is RAM volatile or non-volatile?
Volatile memories.
Volatile. Everybody? Volatile, non-volatile? Any confusion?
No,
Any
sir.
confusion for RAM? That why it is non-volatile, why it is volatile? Cool. So yeah, RAM is also volatile in RAM is volatile in this case, and BIOS is non-volatile, and the HDD SSD that you see is also non-volatile. So this is what happens when you switch on the computer, and this is a general booting process. But when you start study about Linux, Linux has a lot of things in between. A few things like grub also comes in between. Grand unifier, some full form is there. So a lot of things are there. You guys can just just read about it once. You'll get an idea. But in a upper version, if you see everything or every operating system boots similarly. Now there is again a small thing that is there inside a motherboard, that is a battery. This is called a CMOS battery. Now you can search the full form. I don't remember the full form of CMOS, but yeah, there is a small battery that is there inside the motherboard. Now what does this battery does? This battery backs up the BIOS chip. So as I told you, the electricity directly goes to motherboard. So electricity does not directly go to the BIOS chip. Electricity does not go to the BIOS chip. There is a CMOS battery that backs up the BIOS chip. Every other thing, you'll see CPU, HDD, SSD, that whatever is there will be backed up by the electricity. But the BIOS chip will be backed up by the CMOS battery. Now, what is CMOS battery does? This is one of the use case of CMOS battery, that it backs up the BIOS chip. One other use cases, like if suppose you are using you're using a system and you're connected to internet. Now if you're connected to internet, that is fine. You can sync the time, whatever is the current time, you can sync in your local laptop or local device. That is doable. But now if suppose you don't have internet and you went to some vacation and you have switched off your laptop for, let's say, 10 days, and now if you have switched off your laptop, of course your laptop will not be connected to any internet because it is switched off. So in that case, if you open a laptop after 11 days, you will find that the time that is there is still maintained. Okay, the current time is still equal to the time that is there in the laptop. Now, how does that happen? That happens using the BIOS chip. BIOS chip is also responsible to maintain the local clock. The local clock of the system or of the motherboard is maintained by the CMOS battery. So not BIOS chip, sorry, CMOS battery. So this CMOS battery is also responsible for maintaining the local clock. Now what? Now if the system turns on, now this local clock, now the system will not take the time reference from this local clock. It will take the reference from the internet or wherever it is. But by the time when the system is off, or is it not working or not connected to internet, it will use the local clock, which will be backed by the CMOS battery. So tell me guys, do you guys understood the booting process? Why BIOS is there? What is post test? Why CMOS battery is there? And why BIOS chip is non-volatile? Everyone, is this covered in your college syllabus, like the booting process?
Not this detail, sir, but they have covered it.
Okay, but yeah, this is one of the favorite questions of an for an interview. Like if somebody doesn't know about, if an interviewer wants to ask you something about operating system, and if they don't want to go that deep, they'll directly ask you, please explain the booting process. And yeah, this is a very favorite question of an for an interview, the booting process. So is it understandable, guys? Like, did you guys understood? If somebody asks you that, okay, how does a system boots up, will you guys able to understand, make them understand? Yes or no? Okay, cool. Thank you. So yeah, that was all about booting process. I would suggest you guys to just go through the booting process of Linux once, because quite a few things that are there. Grub and all a few things are there. We will find very interesting when you will study about it. And if you guys have any questions, you can ask in the next class for Linux. So yeah, this was all about booting process. Now we'll see what is process and what is thread. This would be covered in a college, hopefully. So what is a process? First, we'll see what is a process. A process is nothing but a program in running state, or not running state, or a program in running state. A running state or ready state, somewhat around that. It would have been written. A program that a process is a program that is in execution. So whenever you click a button, whenever you open an application, whenever you do anything, there is a program created, and a program is created. So it does not mean that the program is running. Okay. So again, there are a lot of scheduling algorithms that are there. So CPU is limited, RAM is limited. So there might be some other processes that are running at that time. So you cannot directly go and give the resources to the program that is generated just now. So it has to go through the scheduling process. So again, whenever you do something, there is a program created, and whenever that program is actually getting executed, because the program, whenever a program is created, the program has a list of things that it needs. So at the end, it needs some resources like RAM, some CPU cycles, a few more things. So the operating system schedules the program, and when the program gets the CPU, and when it is running, when it is in execution phase, that thing is called a process. Okay. So it is just simple. Like a program that is in execution is called a process. Now, what is a thread? Thread is nothing but a lightweight process. Lightweight process. Now, why do we call it as a lightweight process? So now, as I told you, when when a process is created, resources are allocated to the process, like CPU is allocated, CPU, okay, RAM is allocated, some hard disk and SSD is also allocated. So this allocation is done to this, let's suppose P1 process. Now, if suppose a P2 process is also running, so P2 process will have a CPU, will have their CPU, will have the RAM, and this two will be separate. It will not be common. The RAM, the part of RAM or the thing that P1 is having will not be equal to what P2 is having. So whatever RAM and CPU is there in P1 will not be same as P2. So this will be independent. So whenever you are creating a process, you are allocating resources to the process. And whenever the process is getting terminated, you are taking all the you're deallocating the resources that you have allocated. So this process of allocating and deallocating is quite costly. That is why we call that process is heavy. When you create a process, it is a heavy process. It is a heavy thing. Now, uh, what is a thread? Thread is nothing but a lightweight process. So, if suppose this is the P1 process which is going like this, a thread you can just take it out like this. A thread will come, let's suppose T1, and this will start executing parallelly with P1. Parallelly with P1. So, whatever P1 was doing, you can make a thread out of it, make a thread out of one of the process, that is P1, and this will start executing parallelly. Okay. Now, why do we need threading and all? So threading is a concept that we brought in just because we want to achieve more throughput. Just because we want to make our CPU busy at all times. So at the end, if a process is there which is running, and if a process needs, let's suppose, two, not two, if it needs 0.002 gigahertz, and the capacity of CPU is, let's suppose, 4 gigahertz. So if you see, there is a huge difference. Now, if P1 is running, there cannot be another process that will come and start running. So the complete resource that is there will be freezed out until this P1 is running. And as P1 is not utilizing the complete resource that is there, what we can do, we can thread it out. So multiple thread we can bring so that it will start executing parallelly. And the process that P1, let's suppose P1 was taking 2 seconds, so it will take 0.5 seconds or 1 second. So it will decrease the execution time of a process. Just understand in that way. Okay. So this threading is not possible in all the CPUs in all the operating systems. So in Windows, threading is generally disabled by default. You have to enable it by going by changing some settings. In Linux, it is enabled by default. So if you want to run a threading program that you can write it in Python or you can also write it in JavaScript or Java. It is very easy to write a threading program. So if you run that program in Linux, it will run smoothly. If you run that program in Mac, it will run smoothly, if I'm not wrong, because Mac is also threading is enabled. But if you run the program on Windows, it will not run because Windows by default threading is disabled. You have to go in, you have to go to the settings, and there is a lot of things that you have to do to enable threading. So that is why people don't prefer Windows much because Windows is quite heavy, and it is not flexible as well as per user. So this is what the difference between process and threads. Process takes more time to terminate, as we know, because it is having a lot of resources. So in order to deallocate the resources, it will take time. But a thread that is there, a thread will be using a thread which is there. This P1 is having the CPU and RAM. You created a T1 out of P1. You created a T2 out of P1. You created a T3 out of P1. So whatever this T1 will use, T2 will use, T3 will use, will be common that P1 is having. So it will take the resources from whatever P1 is allocated with. So there is no separate allocations or separate resources for threads. Okay. So that is why terminating thread is not, it does not take much time and it is light. So process takes more time for creation. Of course, process if we are doing the allocation part, so we need to figure out how many CPU cycles the process wants, how many CPU cycles we have to give at that point, how much RAM we have to give at that point, and other things. So these all things takes a lot of time. So it takes time for creation. But yeah, thread, we already know that what CPU we want to give to the thread. We don't have to calculate stuffs and other things. So that is why it takes less time for creation. Now process likely time for context switching. Now what is context switching? We have not discussed it, but yeah, when we'll discuss, we'll get to know. Process is mostly isolated. Yeah, as we saw, is mostly isolated. So there is a case. There are processes that are dependent processes. Dependent processes in P1 and P2 will share something in common. That is there, but that is a future topic that we'll study. But mostly they are isolated. So if they are isolated, that means the resources that they are allocated with is not in common. But yeah, threads share the memory. As threads are coming out from the same process, and process has a set of resources allocated to it, so thread will share the memory and the resources. Process does not share data, thread share data with each other, as we know. So understood, guys, about process and threads? Did you guys understood about process and threads, everyone?
Sir, can you explain the context switching part also?
Context switching is not, we have not covered it, no? So when we'll see what is context switching, then we'll discuss about this. Context switching is nothing but it's like uh, what happens is when a process is running, if you remember about multi-programming operating system that we studied in the last class. So what was happening is there were two type of times, okay, IO time and CPU time. So when the process was running inside the CPU, it was utilizing the CPU time. But in some case, what can happen is a process can do a IO work also. If it wants to copy something or if it wants to do some printing work or something. So that is not considered